this is Jo from Maths Tutor Me. Today we're doing factors, multiples and indices, and we're learning about primes and composites today. A prime number is a number that has only two factors, itself and 1. Okay, and a composite number is any number that has more than two factors. So that takes care of all the numbers in our number system except for the number 1. The number 1 is not prime or composite because it has only one factor. Okay, so remember, it has to have two factors to be prime, okay, which is itself and 1. But because there is only the factor 1 in the number 1, it only has one factor. So it is not prime or composite. It is different. It is special. Okay, so today, first of all, I want to show you a method of how to find the prime numbers between 1 and 100. And it's using what is called the Sieve of Eratosthenes. Okay, so he was a Greek mathematician from long, long ago, and he developed this sieve to find prime numbers. So first of all, we have to set up our numbers from 1 to 100 in a grid, which I've given you here. Okay, and what we want to do is basically eliminate all the numbers we can by finding all of our composite numbers. Okay, so what we have to do is we have to go check all the numbers up to 10, okay, for all of the composite numbers, or multiples I should say, coming from those numbers. Let me show you what I mean. So we start with the number 1. Okay, now 1 we know is not prime or composite. So what I'm going to do, because it's different, I'm just going to put a circle around it. Okay, it's a special different one here at the beginning. Now if we look at number 2, 2 is a prime number because it is 1 times 2 is 2. There's only 2 numbers that you can get. So it is a prime number. But any number that you can multiply 2 by will become a composite. So 2 times 2 is 4. So that's going to be a composite number. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. Okay, you get the idea? 2 times 6 is 12. So you might start to realize actually it's going to be all these numbers down here are going to be numbers that can be multiples of 2. And all these ones down here are multiples of 2. And all these ones down here. And all these ones. And all these ones. So that got rid of a lot of numbers straight away just by looking at the number 2. Then we look at the number 3. 3 is also a prime number because it's only 1 times 3 that makes 3. But now we want to look for the multiples of 3. So every third number, 1, 2, 3, that's already been crossed out. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so it takes a little bit of time, but we've been able to eliminate a lot more numbers. Okay, so we've checked 1 and 2. 4 we actually don't need to check because it was a multiple of 2. Every number that is also a multiple of 4 was already crossed out when we crossed out the multiples of 2. So let's go to number 5. 5 is a prime number because only 1 times 5 makes 5. So, but we need to cross out the multiples of 5. Okay, so that would be going 5, 10, 15, 20, 25, 30. Okay, so basically it's going to be anything in this column with a 5 at the end of it, and anything in the tens which has already been crossed out. And now we need to check for 7 because we've already crossed out 6 like before, so We're up to 7. It is a prime number again, and now we need to look for the multiples of 7. So we're going to check every 7th number. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Finally got one to cross off. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And we're done. So now that we've completed our sieve, all the numbers that remain are prime numbers. So you can quickly do this sieve for yourself when you need to do questions on prime numbers, or you might find that you actually start to memorize which ones are prime. So let's have a look at some questions that we need to do using this grid over here. So question 2, list all the prime numbers between 20 and 21. So looking at my sieve over here, after 20, I have 23 as my first prime number. Then I have 29. Keep going, 31. 37. And that's the last prime number before I hit 40. Question 3, state whether the following numbers are prime or composite. 83, if we look at our sieve, it's still not coloured in, so that means that that number is prime. 27, you might recognise straight away that that's 3 times 9, so of course that's going to be crossed out because that is composite. So if you can think of something other than 1 times 27, other than 1 times the number, that multiplies to give that number, it's going to be composite. So 51, can you think of anything that times it to give 51? Well, it is actually a composite. Okay, question 4, find the sum of the first 3 prime numbers. So looking on our sieve, 1 is not prime, remember, so don't count that. Our first prime number, and our only even prime number, by the way, is 2. So we want to do 2 plus 3 plus 5. The first 3 prime numbers, that's going to equal 10. Question 5, what is the largest 2-digit prime number whose digits are both prime? That's up to 100, of course. So 97 is the biggest number in our grid, but the 9, if we're looking at the digits itself, 9 is not a prime number, so we can't use that one. The 8s aren't going to work either, so we're going to have to go down to the 70s. 79, and 9 again is not a prime number. 7 and 3 in 73. 7 is prime and 3 is prime. So 73 is our largest 2-digit prime number, okay, whose numbers are both prime. Okay, time for you to do a few questions. Here are some questions I'd like you to try. Pause the video and give these questions a go, and then restart to see the answers. So for question 1, how many prime numbers are less than 20? So if you're looking at your sieve, you will notice that 2, 3, 5, 7, 11, or you might just be listing these off if you know these numbers, 13, 17, and 19 are the prime numbers that are less than 20. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers that are prime numbers that are less than 20. Question 2, true or false? 1 is a prime number. Now remember, 1 is not prime or composite, so that is actually false, F for false. B, 2 is the only even prime number. That is true because every other even number will have 2 as a factor, so making it a composite number. C, 43 is a composite number. That is also true. Okay, and D, there are no prime numbers that end with the number 8. Okay, that is also going to be true because if it ends in an 8, it means it's going to be an even number. So 2 is going to be a factor, making it composite. Question 3. Prime numbers that are separated by only one number, which is an even number, are called twin primes. List all the twin primes less than 100. So, looking at your sieve, you would see 3 and 5 are two odd numbers or two prime numbers that are right next to each other, and there's just the number 4 that's in between them. There's also 5 and 7. And they're called twin primes. Keeping looking through the sieve, you'll find 11 and 13, and 17 and 19, 29 and 31, 41 and 43. Mustn't be too many left. We have 71 and 73. And I think that's all. Okay, so that's the end of our lesson today on prime and composite numbers. Keep practicing and join me again next time. Bye.